Another thing which is a bit of a challenge is the defender versus attacker perspective. So all of us who develop code, are you guys developers, or what are you? Developers, raise your hand. Sort of, keep it down. So pretty much all of you are developers. So in that role, we really want to take the defender perspective and create some solid code that can withstand attack. And that is quite a challenge, because it means we need to find all of the security bugs and get rid of them. So it's not enough to find one or two or three, we need to find them all. But finding them all is an impossible task, so we need to find enough of them to keep the attackers out. The attacker has a much simpler job. All they need to do is find one security bug and they're in. So it's being a pen tester or an attacker is quite an easy job on a normal piece of code that haven't been hardened. It's actually pretty easy to find problems. It's much more difficult to find problems on an industrial scale and get rid of them through your development process. So two things that are difficult: a lot of problems, and we need to solve them all. Oof, this is getting hot in here as well. There are some things that work to our advantage. We who have developed the system, we actually know how it works. So we can take shortcuts in our understanding and build that into how we design security. The attackers that come from an outside perspective, they need to learn about the system. So we can take more of a white box approach, and they have to pay a little bit of tax doing the black box approach. So I mentioned that there was no such thing as secure software. That means that you have to be prepared to be hacked. So basically someone's going to find something in your product or service or whatever you're doing. Which means that you need to be able to react to that fact. So you need to set up some sort of capability to work reactively. That, of course, is a challenge, because the more time you spend on reactive work, the less time you have to do the proactive stuff. So you need to find a clever balance. And when you set up, for instance, like an incident management program where you get stuff from security researchers and try to fix it, you need to make that really efficient, because you don't want to spend a lot of time putting out fires that are in your product on the market. You want to put more time on your proactive work, and that's really a challenge, because typically the thing that wakes you up to software security is something like this. This is an email from one of our security researchers working on one of our products. It's a few years old, but basically this guy found a vulnerability and reported it to us. From a vulnerability perspective, it wasn't anything special. What's really interesting in this email is the amount of time he spent in developing the exploit. It took him 6 months. That shows some real dedication. So there are people that put in a lot of time and effort on testing your products. So the way you deal with this, you need to be really efficient. You need to be good at giving these type of guys good replies, so they're friendly to you. You need to have the capability to fix stuff, and you need to be able to roll the fixes out to your products. So without software update capability, you're pretty much screwed when you get something like this. And that varies a lot from industry to industry. So the industry I'm in, we are doing mostly devices. So when a thing like this comes in, we had to do fixes in 50 software versions and roll that out to 200 products. And that was a lot of work. Fortunately, I didn't have to do any of that, but they told me it was a lot of work. So in a large development organization, or in an effective development organization, you're going to have a lot of developers like you guys committing code to your code base all the time. So there's a lot of stuff coming in. And since you guys aren't perfect, like none of us is, you're going to commit security bugs to the code base. And if you're really efficient, you're going to actually commit a lot, because the more code you produce, the more security bugs you produce. That's also hard for the mind, right? So in this context, what you really want to do is you want to help your developer community to produce better code, so you don't get all this stuff into your code base. And you really want to do that as close to the developers as possible. So you really want to stop the inflow. My personal experience is that that's also a much easier approach than looking at the legacy code, because it's actually easier to do the new stuff you're doing a little bit better than the old stuff you did 2 years ago. So it's actually quite good from a motivational perspective to start with the new stuff. So that's the thing to think about. Where should I start? Should I start with the new stuff, or should I start with the really, really scary legacy code? So if any of you guys are maintaining a system that's old and where people have committed code and developed on that system for years, you're going to have a pile of security bugs. And we're not talking hundreds, or we're talking thousands. And that pile is not going to be fun to walk through. So you need to create a strategy for how to approach that. Should you go at it all at once? Should you stop all development and go fix all the bugs in your legacy code, or should you try to do that in a more clever way? It's really up to you and your environment, but developers don't take kindly to stopping everything and just going about fixing security, all the old legacy security bugs. But it's a thing to consider. There's going to be a lot of skeletons buried in your code. Okay, so we had a whole challenge of finding all the bugs, and we had all the challenge of all the bugs that were in the old code and in the new code. So what should we look for? What does a security bug look like? And that's a really hard question to answer. The common weakness enumeration, it's some guys that created a sort of an inventory of typical security vulnerabilities. That inventory right now contains 714 different types of vulnerabilities. So when you look at your code or your application, you need to consider all these 714. And that's a lot. That's more than any of us humans can do, right? So what people have started to do is do top lists instead. I can't bother about all those 700. I do the top 25. But 25 is a large number for a human to remember things about. So you go to like the top 10 or something. But that's a really big challenge for you guys. So whenever you start looking at your code and you want to improve it, you need to figure out what you're looking for, because you could be looking for the wrong things. So what we try to do is don't have too much of these top lists from the get-go, but sort of build that from the knowledge we have in our code base. So as we look at stuff in our environment, we learn what's the typical patterns for us, and we're basically creating our own top lists. And that's the thing for you guys to consider. What's really the common attack patterns for my environment and my application? That could have been the closest thing to a techie slide in this entire slide set. I apologize for that. So now we're moving into the really sort of soft aspects of software security. So when you create a software security initiative, the easiest way to start out is to get somebody who knows something about security. Perhaps a few of them, and put them together in some sort of centralized software security group. And those are the guys you go to with your code, and they review it, and they review your architecture, and they do the pen testing and whatnot. So they do all the work on behalf of all the teams. And in some contexts, that's a good approach, because you're probably going to get some really good people if you have enough money. And they're going to do a great job finding a lot of relevant security problems. The problem is, if you have a lot of teams that are really agile and really, really work on your code and are super fast, this immediately becomes a bottleneck, especially in like DevOps kind of environments. Shipping something off to some group that should review it before you can put it in production, I don't think so. So this works for more like older style development models like waterfall, or if anybody still does something like that. approach we have taken is sort of the opposite. So we put the team in the center. And that goes all the way back to me calling myself security coach. So the teams will do all the work, all the security work. They do all the security analysis and they fix all the security problems. And we just cheer them on. Come on. That avoids bottlenecks because the teams are empowered to do their thing. So you get a really, really fast cycle if you're good at it. And you also get the teams to take responsibility because they can't sort of blame anybody else, the security guys coming in after doing the review kind of thing. They're responsible for the whole shebang and they learn how to do it and they'll produce better code moving forward. Then, of course, if you are a really large development organization like we are, where we have some 800 developers we need to coach, you need to get a little bit of help. And the way we're doing that is through a concept we call satellites. And that's sort of security hangarounds. It's people in the development teams that are really interested in security. And sometimes they are really, really good. Really, really good. They're responsible for the day-to-day work out in the teams. Basically, supporting the teams with any questions they have around security, making sure that the security work happens in the teams. So I think we have a setup of around 15 of these satellites supporting our organization right now. And it's super cool to have that kind of community because all of a sudden there's an inflow of new ideas and new cool things we can do. So that's a really powerful concept. You need to think a little about the competence profiles you have in your security people. Because security nowadays isn't sort of a skill that one person can master. And I mean, that's also a little bit hard. But what has happened over the years is that there are more and more tools and skills you need as a security practitioner, making it basically impossible for one person to be the security guy. You can't have that much knowledge anymore. So you need to consider people who know how to do security when you work with your requirements, people who know how to talk to your product owners. You need to have architect type of guys and girls that can do architectural analysis. You need to have people with code review skills during the implementation phase. You need to have people who know how to do test automation and penetration testing. And that's pretty hard to have in one competence skill set. Since all of you guys raised your hand on being developers, I know you're kind of centric over here. But it basically means that when you set up a security team, you need to consider having different skill sets, meaning that it's probably so you need more than one person to do your security work because it's something that's spread across all the aspects of software development. Police versus coach. This is super hard. Traditionally, we who have been around in security a long time tend to act as police towards developers. We sort of find bugs and we tell developers you're stupid and you need to fix it immediately because you're so stupid. That's not a good way to create relationships with your development community. It's actually a disaster. So you need to take a different approach and be more of the good cop and the coach and really try to get involved with your development community. And actually, you don't have that much trust capital. I think you can do that once or twice, but once that you're burned in your whole developer community. In one of the places I've been, we had an excellent pen tester. He was great. I mean, he was so good. He could take any system apart. And he could find a gazillion of bugs in anything he looked at. And he did. And we sort of released him onto the developer community. And after a few months, he sort of came back and said, I don't know what projects the guys are working with anymore. They're hiding from me. So he basically scared away the whole developer community. So instead of doing security work or engaging us, we had no clue what was happening. So guys, don't do that. Don't be jerks. Be nice. Okay, so we're building up towards a point where we can make the conclusion that software security is sort of a cultural thing in your development organization, and making cultural changes in a development organization is pretty hard from the bottom. I mean, you can make a little bit of a change as an individual contributor or developer or security guy, but you really, really need management support. And this slide, I'm worried about filming this, right? But this is actually our CTO and our head of R&D. And this is a slide we put together in our awareness training. So we did awareness training for all our 800 plus developers. They had to sit in a big auditorium, and these guys were presenting. They actually presented this slide. I don't really recall what they said about it because they never liked it a lot, but the whole concept was for them to say software security is important. And they told that in person to all the developers through that awareness training. And basically the other thing around that was that it sort of opened a lot of doors for us. So whenever we want to move around in the organization and coach the teams, the doors are already open because software security is a priority for our organization. And that message comes from the top. Of course, these type of guys want to open doors, but they also want a little bit of control. So they're also making damn sure that we're not slowing down development with the activities we're doing. So you actually want to engage, you want to engage your management both as door openers, but a little bit as holding you back as well, because as a security practitioner, you can generate a lot of work for your development organization. Okay, so that was sort of trying to describe some of the challenges. You guys feel it's software security is a simple thing? No? You're waiting for pizza? Yay! So I'll talk a little bit about the toolbox you need when you sort of look for security bugs. So first of all, there is no single tool or technique you can use to find all security bugs. There is no such thing. So if you believe in sort of silver bullet, forget about it. You have to do a lot of different things. So some security problems you can only find by looking at the architecture. So you need to do stuff in your architecture phase or with your architecture to find those security problems. Some stuff are only present in the code. You can only see them by looking at the code. So then you need to do code review. And some stuff you can only see by testing things. So you basically need a toolbox that covers aspects from architecture to code review to test type activities. So the way we're doing this in our first iteration is that we're doing risk assessment in the requirements phase. We're doing threat modeling. We're doing threat model triggered code review. We're doing threat model triggered testing, internal pen testing, and even some vulnerability management. But this is just like a beginning. This is just a quick start of where we need to go. So whenever you set up your toolbox for your organization and your developers, you need to consider what type of security bugs can this find and what do we miss. So in our case, we're pretty strong on architecture stuff. We're pretty strong on testing stuff, but we're kind of weak in the middle. But that's okay. It's a starting point. So how do we handle a situation where we can improve? Then of course we need to build improvement into the way we work with our toolbox. So we really want a roadmap for our security toolbox. So the things we do today are not the same things we do tomorrow. And as we do stuff, our developers gives us lots of feedback so we can change. And trying to keep a quite tight iteration cycle on rolling out new things means that we can sort of improve the stuff we're doing so we can do more secure code and even perhaps do it more efficiently. In a large organization, this is a challenge because each time you make a change, you need to make that change reach all your developers and train them in using that new tool or technique or whatever you're doing. So it's a bit of a challenge. When you do security work, regardless if you're doing architecture analysis with threat modeling, or if you're doing some sort of code review, or if you're doing pen testing, you're always building some sort of mental picture of your system. You're trying to understand how it works, and you try to sort of figure out the things that can go wrong. And basically, if we work in silos, so our threat modeling is completely isolated from our code review, which is completely isolated from a pen test, then basically all these skill sets need to build the knowledge of the system on their own. And typically, you spend more time trying to understand the stuff than actually understanding the security problems of the stuff. So I could say that my experience from doing a lot of threat modeling is that you do 75% understanding the system and 25% security work. I don't know the figures for the other practices, but there's a lot of time spent on trying to figure out what the hell you guys have implemented. So to make that a bit more efficient, we want to share knowledge around all of this. So when we do some exploratory testing, or when we do a threat model, or whatever we do, we want to share that knowledge between all the people working with security. So that knowledge sharing is key to make your stuff efficient. Another thing that happens if you have isolated silos is that as you file bugs or improvements, you need to prioritize them. And what if the pen testers start to put really high priority on all the stuff they're filing, while the architecture guys are, it's not so bad. Then you start fixing a lot of stuff from this end of the spectrum, but nothing on your architecture. So you really need to think about calibrating how you measure severity in your security development model. Otherwise, things can go out of hand quite quickly. So we typically, I wouldn't say go so far as to say we use CVSS, but we're inspired by the Common Vulnerability Scoring System. Use any scoring system as long as you use the same measuring stick across all your activities. One good thing about using something like CVSS is that since that's a public standard, once you get reports from external researchers, you can actually calibrate their work to your internal work, and that's quite neat. So sliding on a little bit into threat modeling. Anyone who's done threat modeling? Yay! Good. I'm so glad. So the way we do that is by first having a session we call threat scoping. We use that so the team can explain what they're doing in some sort of high-level perspective. From that, we generate two things. We generate a list of attackers. So basically the attackers we want to consider when we do the threat model. And that really gives us sort of the level of security we will have after having done the threat model. So if we have sort of these guys, the internet attacker and the local network attacker, we get one security level. But if we have some other hardware attacker that's inside the box and playing around with the hardware, we get to do different threats and different countermeasures. So we get a completely different security level of whatever we're looking at. And it's also super good to do this up front before you start doing the threat modeling exercise, because when you do that with a development team that's creative, they're going to come up with all sorts of stuff that will scare you. So you need to put them a little bit in scope. So that's one piece. The other piece we do is identify a set of use cases that really touch all the parts of the system. And then we use those use cases as the basis for the threat modeling. But that's also super important, because if you have a lot of use cases you need to cover, or if you don't know what end you want to start, you tend to waste a lot of time. So we really want to do that in a use case way. It's quite natural for most development teams to sort of walk through things in a use case fashion. The actual threat modeling is pretty classical. We do data flow diagrams that follow the data flow in the use case. We sit down and think about threats. We are not using Stride or any of the standard methodologies. because we can. So we sort of rolled our own, really trying to inspire the developers to come up with the threats. Instead of having like complete lists where everything has to be sorted in boxes, it's more like triggering the thinking among the developers. And that's why we have some stuff on our shortlist, and then we always have the star going for whatever you can come up with. And we shouldn't be too worried about if we find too much or too little. The good thing is we find real security problems in the architecture by doing this. As we have done this in 20 teams by now, we are starting to learn the patterns that are common for us. So SQL injection, path traversal problems, cross-site request forgeries, yeah, they're common to our environment, so we start to make them a part of our checklist. But they weren't there to begin with. We sort of learned that from what's actually relevant to our environment. So once you've done your threat model, you have a result. So you have some identifier of the threat, you have a severity, whether it's something bad or something not so bad. Again, calibrated according to CVSS. You have your threat. Once you have that, it's actually pretty trivial to define the countermeasures. So coming up with the security stuff you need to build is actually trivial once you know the threats, because you just look at the threats and come up with some countermeasures. It's actually very, very rarely you'll even have to think. It's TLS this and it's cookies here and it's whatnot. But it's pretty straightforward. It's quite fast compared to understanding the system and identifying the threats. And that may sound a bit weird, right? That the actual security work is fast and all the other work is where we spend time. But that's true. This is the way it is. So once we've done our countermeasures and threats, we're still in a situation where we have sort of a theoretical analysis. So this is just paperwork up until now. So we have threats and countermeasures, but it's just thin air. What we really need to do is make sure we figure out whether these countermeasures are implemented or not. Sometimes the stuff we find actually already have countermeasures that are implemented, and sometimes they don't. And if they don't, we need to put stuff in the team backlog, because that's really the first time where any of this security mumbo jumbo has effect, when it becomes a part of the team backlog and the team actually needs to take action on the security finding. We do the same sort of exercise for the test cases. So if the team has implemented something, we sort of ask them, do you guys have a test case for that? And they always answer no, and then it goes on the backlog. And to make this work across lots of teams and lots of components and lots of software, you need to make good links between your threat modeling and whatever systems you guys are using for managing your backlogs or test systems. So there are lots of ways of doing this, but you need to have that sort of traceability, because otherwise, as a security practitioner, you have no chance of actually knowing the security status of your products. So a bit of bureaucracy, but it's super important. Code review. So why should we do code review from a security perspective? So first of all, at least half of the problems we have are problems that derive from the way you have implemented things. They're not architectural problems. They're just programming mistakes. So there's a lot of stuff. There's a lot of stuff to be found using code review. Again, it really depends on what programming languages you're using. If you're old-timers and using C and C++, there's a lot to be found. In these weekly type languages, it's bug bonanza. In more modern languages, perhaps not so much. These kind of figures also represent our situation. So if we look back at the sort of incidents we've had over the last 3-4 years or so, probably half of them come from programming mistakes. And it's worth noting that in this environment, we as an organization have always done code review. We have done a lot of code review and really good at code review, but we never did security code review. So we never found any security bugs with the normal code review. So if you want to do security code review, you can do it manually. there are some benefits of doing that. If you're good, there are a few false positives. The stuff you find is actually real bugs. You will actually be able, as a human, you will understand architecture by doing the code reviews. You will find architecture stuff. But there are some pretty serious downsides to this as well. One of the downsides is that if you have a lot of code to review, it tends to get boring. Several of the classes of implementation bugs are really, really hard to spot when doing a code review. You need to be super focused and follow all the input paths, and it's super hard. And you need to train your developers how to do that. That's not a trivial task. Come in. So the whole training your whole developer community to being able to doing the manual code review is it's not trivial. So then you could consider doing automated code review instead. It has some benefits. I mean, it will scale well. Tools will just walk through your code and find all sorts of problems. They will look for all sorts of problems as well, because tools don't get bored and they can keep many things in mind. It can even be used as a way to train your developers. So the feedback you get from the tool is actually the thing you needed to learn about how to code. But tools are also super, super dangerous, because they can produce a lot of false positives and an enormous results which you can't handle. So on one side, I like static code analysis tools, but on the other side, I'm super scared of them. And one way of addressing that is by thinking about how you integrate the static code analysis tools in your development workflow. So you have several options. You can integrate the tool really close to your developers, preferably in their IDE. So as soon as you write something and try it out, you get feedback immediately. Then you get that training aspect, and there's not that many bugs found, so you don't get the pile of stuff to look at. So that's a good thing. That's a good way to integrate towards your developers. But then, as a security person, being forced to say something about your product or system, you probably need to look at the whole result. But be careful. There are some things you need to think about when you get that result. Never show it to managers. Don't allow them to create a KPI out of it. In one of the places I've been, we integrated a static code analysis tool. The managers said this is a key performance indicator. We need zero bugs from the static code analysis tool. All teams go to 0. And there were thousands of findings from this tool. And the teams had to work and work and work. And after that, the only thing that happens was that they really hated software security. So don't do that. Don't fall in that trap. I've done it twice. On the verification side, the way we have set up things is that we derive most of our test cases from the threat model. So the threats we have identified in the threat modeling, we use to derive our test cases. We actually even do some dedicated code review triggered from the threat modeling. But most of it goes into unit tests. That's the preferred way. So then we're close to the team. The result is handled by the team, and it goes into a test case owned by the team. Then as we sort of move into sort of a bigger system, then of course we may have to do stuff in the system test suite, preferably automated again. And then as we move out, fewer and fewer things are left to be tested manually. So basically you will have your pen testing over here somewhere. This has proven quite efficient, because you can take any tester with any sort of background and they become a security tester by being integrated in the threat modeling done by the team. And that's kind of mind-blowing. So you're sort of producing your little pen testers as you go along. So much for the security toolbox. Then a little bit more of this fluffy stuff on how to integrate stuff in an organization, how to get things done. So whenever we are teaching a team to use the toolbox, we're basically doing a very, very short onboarding session with a little bit of training. We don't believe in classroom training at all. We do a little bit of introduction PowerPointy stuff, and then we try to move as quickly as possible into doing some sort of security assessment on one of their components or features or things or whatever. So we can actually start working together with the team, doing real security work on their code instead of showing PowerPoints. And that's really nice, because then we can sort of work together and see how the team works, and we can tweak the model according to how the preferences of the team. We try to put a time box on that. We didn't do that in the beginning, so we kind of got stuck with some of our favorite teams. Just kept on looking at their architecture and finding more and more stuff and digging a deeper and deeper hole. The way we do things now is that we actually time box this exercise to 3 weeks, 4 weeks, something like that. And we leave the team when we believe that they can do this work on their own. Not when the analysis is done, but when we believe that they can do it on their own. And all of the teams we have done so far have been able to do this on their own. Some even get really, really good at it. But that's key, because then you start actually building the security stuff into the way they work. So we're there to support them in the beginning, but then we back away so they get to use the toolkit themselves. Then, of course, unless you do some sort of follow-up, the ball stops rolling. They will stop doing these things if nobody asks questions about it. So after having rolled out the security activities to a team, we try to meet them once every month or once every quarter, just to check up on how things are going, to remind them to do a little bit of security work. And that's also a good opportunity for them to give us feedback on how all of this works. So if you're a large organization, you have lots of developers and lots of teams. Where do you start rolling out your security work? Where should you start? So one thing you could do is you could create a risk heat map of your system. So which are the most risky components we have? Where are we worried? And you don't need to be very scientific about this, because probably your gut feeling is good enough. Already now, without knowing anything about security, you're probably going to be really good at doing risk assessments. But I worry about that system. Yeah, let's start looking at that system. So in this case, it could be some sort of cloud thingy that we are mostly worried about. So let's start with that component and with the teams developing code for that component. This reasoning also applies when you need to start looking at your legacy code. You can't just start looking at everything at once. You need to do some sort of risk assessment and find hotspots where you need to start. Otherwise, you'll just drown. So risk heat maps are really, really good. So being a security coach in a team that just does coaching, it means that our entire backlog just consists of rolling out security to teams. But we need to prioritize that as well. And the way we've done that is, again, according to the risk heat map. So the high risk, or teams dealing with high risk components go high on the backlog, and the other ones go a little bit further down. And then we sort of work through the organization, team after team. We sort of get them to do the security stuff. And at some point, we're through with all the high risk guys and girls. So then we're probably in a decent position, although we haven't really reached all the teams, but yeah, we can start sleeping at night. So it's really good to have this sort of knowledge, because if you don't plan it this way, you're probably going to get lost, wandering planlessly among your teams and don't get anything done. Okay. Almost 45 minutes of talking, and now this is the most important slide. You need to handle the result of your security analysis. So I said put stuff in teams' backlogs. They need to get fixed as well, right? Because if we don't fix anything, all of this was totally, totally useless. So here we have 3 different systems or teams or whatever you want to call them. The little darker yellow is high risk findings. That could be countermeasures they haven't implemented or test cases they haven't done, right? So stuff to be done that's linked to high risk threats. And then the lighter stuff is medium severity threats. The low stuff we didn't even care about tracking. And the green line represents how much the team is actually fixing. So here you got a team that have done a lot of analysis, they found a lot of stuff, and they actually were able to fix stuff. So the amount of problems they have in their code is actually being reduced. So this is a good team, or a mature team. This is another team. They're still learning. So you can see their analysis curve goes up. They're doing a lot of analysis work, a lot of good analysis work, but they haven't come around to fixing stuff yet. And this other team, they're total noobs. They just started. But you can actually see maturity. This is kind of typical. When you start out just with analysis. You find a lot of stuff, and you find stuff, and then at some point you start being able to fix it as well. And this type of statistics we actually show to our management as well. Not because we want them to chase us, but because most of our developers want to get this fixed. They really want to fix stuff. But the product owners and the other guys have so many other high priority things to do before that. So by showing stats like this to your management, you can tell them, look, our system is crap. We need to do something about it. There are security problems, and they will listen. I promise you guys. Okay, so with that, I want to conclude this little talk. I hope you got the picture that software security is a little bit difficult, but a bit exciting. There are ways to actually approach it. There are technical ways, and most of all, it's all about getting security into your development culture. So that's all I had planned. Any questions at this point, or we're getting pizza now? Yeah, please.
Thinking, how do you define what is security problems, or what security issues? I guess it's different from company to company, from product to product.
So basically, yeah, we don't have a stringent definition, but basically, if it is something, a bug where there is an attacker, there has to be an attacker that does something malicious. So all these three conditions need to be fulfilled. So if there's like cosmic radiation causing your software to crash, it's not a security problem. But if there is somebody that can inject something that can make your application crash, that's a problem. And the effect part is super important because it actually has to have some sort of negative effect, because if they do something and all of a sudden it starts working better, it's not a security problem, right? Good question. I think I should have had that on the first slide. Any more? Yeah.
So you have 10 security pipelines, like, and there's the risk assessment and test and so on.
Yeah.
On that one. And it's usually, I think the problem is that the risk assessment usually is just a copy-paste from standards, and pen testers just take them and on the bit. So does the satellite model that you have active people on with a team help with that in translating problems back and forth, so the risk assessment becomes about the project better and
Yes.
so on?
Excellent. I mean, that's the best question ever. So we always hate checklists. Checklists are always bad. Standards are actually bad. You need to be contextual. All security problems depend on context, right? So it means when you make a risk assessment, you actually do that on your particular problem. And the way we're doing it is by having satellites or other people being involved in the team's planning, the backlog planning. So basically, when you put stuff on your backlog, that's when you do the risk assessment of that particular thing. And we don't have a checklist for it. It's basically, does this feel dangerous? If it feels dangerous, we should do more security work. If it doesn't feel dangerous, we're good to go. We won't do any more security work. So we're actually already in the risk assessment phase, sort of let features go. This is a UI change. Don't bother about security. And it's actually super important for efficiency reasons, because then you get to do the minimal amount of security work. because you only do it on high-risk stuff? Thank you for that question. Yes, please. Yeah. Oh, it's super hard. I mean, it's so hard. It's so hard. Uh, Often management only reacts to external crisis. So I have colleagues who have been preparing our security program for years but never got anything done because management didn't have it as a priority. So I don't have like an answer how to do it, but it's a super difficult problem to solve. Yes. But usually you can scare them because this scary pen testy tactics works on them. Yeah, but it is difficult. It is difficult. And I mean, if management does not believe in software security, you can't get it done, and it was probably not important for your company. Yeah. But it's hard to create a business case out of it. Unfortunately, the scary tactic is the one that exists, and that's kind of sad. But competitive advantage is much better. Yeah. But there is another sort of, if we sort of lift our eyes from our own organization into the way software is developed in general, people started doing this like 15 years ago in the West Coast in the US. And that wave has been slowly moving around the world. And it sort of reached Europe a few years ago. And then if you take different industries, that wave lags behind even more. So like IoT industry, it's later. Automotive industry, it's later. But as things mature, it becomes a hygiene factor. So they can't hide. It's going to become like quality. You have to do it. But it takes time. Yeah. There was another question.
Yeah. What is your approach for third party code? Do you treat it as your own code, or how big percentage is usually of the final product?
Yeah. So you're absolutely right. A majority of the stuff going into the products is likely to be third-party code. And we are not using this methodology on third-party code because it's too expensive. We have no chance of doing all this security analysis of third-party code. So we do much more lightweight processes where we do vetting on, is this a decent project? What's their track record? That kind of thing. But it's not at all in this level of detail. So you need to put a lot of trust in your third-party vendors. It's a leap of faith. But I mean, if you use stuff that the bigger guys have used, and not the code, for God's sake. No, for God's sake. We basically look at their track record of bugs. Because as soon as you do more than that, it becomes super expensive. And then you need to treat them as like an integrated part of your company. And with open source, it's kind of hard to put requirements on them. You basically need to put people on your own people on that problem. But if it's something we buy, then we could put requirements on them. Yes. Yeah, so there are a lot of tools you can use. I mean, if you're in a Docker environment, you got tools in Docker and all sorts of tools. So that's a super good approach. Again, tools are a bit chatty. So they will report all sorts of problems all over the place because everything is broken all the time. So you need to do clever triage on that. But there are some good tools out there. Great questions. Do you dare? No. Okay. Good. Thanks for listening.